So in this video we are going to construct a development of the cylinder. So cut it by section plane at an angle of 45 degree on either side. You can see we have to draw the development for this. So first I'll be drawing XY line VP HP XY, then drawing a circle for diameter 50 mm. Then we divide the circle into 12 equal parts, that is we'll take an angle of 30 degree here. So 30 degree, 60 degree, 90, 120, 150, 180, like that we draw, and then basing extend to next command. So we are going to extend these lines. You can write the naming for it. Show the dimensions and draw the projection lines from all these ends to draw the front view. So the outer lines will be thick lines, the inside lines will be thin lines here. So the front view of the cylinder is also a rectangular face. So constructing all the lines here. Okay, so show the dimensions. You can see we have to taking the top face center. You have to draw two 45 degree angle lines on either side as it is shown in the figure. Okay, for that I'll be drawing the front view of it. So drawing the front view notations here. So now I'll be drawing the section plane. So from the top face center, by giving an angle of minus 45 degree this side, and from this side it is minus 135 degree. So I'll be making the upper part as a thin part. So we have to show only the lower part as the retained portion after the section plane cut it. So by selecting the upper part, I'll make the upper part as thin line here. Okay. Now for the cut plane, I'll be mentioning the numbers here. Okay, now I have to draw the parallel line here. Line had to be drawn parallel to the axis, parallel to the XY line here. Okay, now using offset command, I'll be giving a length of 157.08. Okay, you all know how to find out, that is pi d. Okay, so that is the formula to find out this value, pi into diameter. So we will get this exact length. Okay, now 157.06, so divided by 12 parts, so the length what we get here, it is, so you can see in the solution book, it is 13.09. okay, so that means we have to offset each of these faces for a length of 13.09 mm. okay, so go to offset, select any vertical edge and type it 13.09, enter, and then you can equally space them into 12 equal parts. Okay, now you can mention the namings here. So just draw horizontal projection line here. So this one, it is cutting on that vertical edge A here. So I'll be mentioning 1 on the vertical edge of A. Same way I'll be drawing the projection line of 2, and it is cutting on a B and L. So that is point number 2 and 12. So on the B I'll be mentioning 2, on L I'll be mentioning 12. Same way, so there is a projection line from 3 and 11 horizontally. So it is cutting on the vertical edge C and on the vertical edge K. Okay, now 4 we are getting on the extreme corner end. Okay, Okay, now we can mention the numericals here. 6 I have mentioned. Okay, 5, 6, and 7 we get at the 1. Okay, on that one projection line, and then we have 8, and then 9. Okay, now from 1, 2, 3, 4, 5, 6, everything here it is should become joined with the curve here. You can see that curve, we have to use it here in order to join from 1 to 12. So I'll be using a curve command. Okay, the thickness is 0.50 mm thickness. You can zoom in and try to connect with the exact point here. Okay, that's what. You can zoom in and try to connect with the exact points. Seven, then 8. Okay. 9 we have. 10 we have. 11, 12, and then 13. So it is joining at the 13 end. Can see now. So this completes the problem. So you can subscribe for this channel and hit on the bell icon and the like button for the latest notifications, and share it to the maximum students so that they can be benefited. So the upper part of this, I'm making it as a thin line. Okay, so the cut part we should make it as a thick here. So thank you for watching the video. Thank you all.